Good morning, grade 10 students. Keep going. Today we'll be solving exercise 6, part 1, exercise 8, also part 1, and exercise 15. Exercise 6 and 8 have also part 2 and 3 in them. So you'll take those as a homework for Tuesday. So let's start by exercise 6. We have the polynomial 3x cubed minus 10x squared plus 4x minus 3. We have to divide it by x minus 3. Okay, let's make sure at the beginning if 3 is a root or not. Okay, we started solving this in class and then we stopped. So we have here 3 cubed, okay, minus 10 into 3 squared plus 4 into 3 minus 3. Okay, by doing the necessary calculations, this is 3 times 27 minus 10 times 9, this is 90, plus 12 minus 3. This will add up to 0 using the calculator. You can know this. So we say that 3 is a root of p of x. Why? Because p of 3 is equal to 0. Now, if p of 3 is a root, we said that p of x can be written as x minus 3 multiplied by some polynomial a of x. Why? Because now if we substitute 3 here, okay, p of 3 will be, we will have 3 minus 3, which is 0. So 3 will be a root of this polynomial over here. Okay. Now, what do we know about a of x? We know that the degree of p of x is 3 from here, okay? The highest exponent in p is 3. And also, if we wrote it p as x minus 3 multiplied by a of x, قلنا نجيب الديجري of p of x, we have to add the degree of x minus 3 plus the degree of a of x. The degree of x minus 3 is simply 1, okay? Because the highest exponent is 1. So this leaves us with the fact that the degree of a of x is equal to how much? 1 plus how much is equal to 3? 1 plus 2 is equal to 3. So degree of a of x is equal to 1 plus 2 is equal to 3. So degree of a of x is equal to 2. Okay. So if the degree of the polynomial a of x is equal to 2, then the general form of the polynomial a of x is ax squared plus bx plus c. Okay, this is the general form of any polynomial of second degree. لو كانت مثلا degree of a of x is equal to 3 كان شو لازم نكتب؟ كان تطلع ax cubed plus bx squared plus cx plus d. This is the general form of any polynomial of degree 3. Okay, it's not the case now, so we'll stick with the polynomial of second degree. Okay, we know also that p of x is equal to x minus 3 multiplied by a of x. So we can write here ax squared plus bx plus c. Now expanding this, x times ax squared will give us ax cubed. Okay, and x times bx will give us plus bx squared, and x times c will give us plus cx. Now minus 3 times ax squared, we will have minus 3 ax squared, minus 3 times b of x, we will get minus 3 bx, minus 3 times c, finally we will have minus 3c. Okay, now we'll group the same terms together, the like terms together. Ax cubed, there's no other term having the x cubed term. Here we have bx squared and 3ax squared are the only terms with having x squared in them. Okay, so we can write plus b minus 3a and take x squared as a common factor. Okay, we have here cx, okay, and minus 3bx. They are the only two terms having the x term. So we write plus, we open the parentheses, c minus 3b. Okay, these are the coefficients. So here the coefficient is c, here the coefficient is minus 3b. So we write the coefficients and we multiply them by x. And finally, minus 3c is the constant term. Now, how do you find these variables, or these unknowns a, b, and c? We have to equate this polynomial that we got here with the original p of x. Okay, so this will be equal to 3x cubed, okay, minus 10x squared plus 4x minus 10x squared plus 4x, and the constant term is minus 3. Okay, so here we have minus 3. Okay, now by comparing the coefficients, we get a is equal to 3. Okay, we compare the coefficients. We don't write ax cubed is equal to 3x cubed. Okay, we only write the coefficients. So a is equal to 3. Now b minus 3a is equal to minus 10. C minus 3b is equal to plus 4. Pay attention for the signs. C minus 3b is equal to 4. And finally, the constant term over here is equal to the constant term over here. So minus 3c is equal to minus 3. Okay. Now we have three unknowns, a, b, and c. So we will not be needing all the 4 equations. 3 equations is enough. Okay. Now a is equal to 3. We have a from here. And from the last one, okay. From the last one here, we have that c is equal to minus 3 over minus 3. So c is equal to 1. Okay. And we can use the second or the third equation. Now, it doesn't matter. They will give us the same answer. Okay, let's try to use the third one this time. So we will have, this will be 1 minus 3b is equal to 4. Okay, how do we continue this? We have, take the 1 to the other side. So minus 3b is equal to 4 minus 1, and b, this is 3 over minus 3, which is minus 1. So now we have a, we have b, and we have c. So we can write this now. Okay, thus p of x is equal to x minus 3 كتبين into ax squared plus bx plus c. Now we don't write anymore the a, the b, and the c because we have the values for these. Okay, so a is a 3. You have 3x squared. B is minus 1, so we have minus 1x or simply minus x, and c is 1, so we have plus 1. Okay, and now we have divided p of x by x minus 3, and the answer is 3x squared minus x plus 1. We can also write that p of x over x minus 3 divided by x minus 3 is equal to 3x squared minus x plus 1. Okay. Now for the other exercise, exercise 8, part 1. Okay, in this exercise, we have to state whether the given value of alpha is a root of p of x. Okay, this is a very simple exercise. To do this, how do we know if alpha is a root or not? We simply find p of alpha. If the answer is equal to 0, okay, then it is a root. If it is different than 0, then it is not a root. Okay, so let's try p of alpha in this example. Okay, so we have p of 2 is equal to 2 into 2 cubed plus 3 into 2 squared minus 5 into 2 plus 6. This is equal to 2 cubed is 8 times 2. This is 16 plus 3 times 4 it's 12 minus 10 plus 6. Now 16 or 12 minus 10 is 2 plus 6, this is 8. So we have 16 plus 8. This is equal to 24. So this is different than 0. What do we deduce? Then 2 is not a root of p of x. Okay, so you can continue the part 2 and part 3 in the same way. And now for exercise 15, okay, we have the polynomial q. It's defined as such. Now in this polynomial, the coefficients of x squared and x are so the coefficient of x squared is here in terms of m and n. Okay, in this here minus into 3m plus 2n is the coefficient of x squared, m plus n is the coefficient of x, and we don't have any constant term. Okay, we do not have any term that does not contain x. Okay, what's the first question? Determine m and n. We have to determine m and n so that q is divisible by x minus 1 and x minus 2. Okay, what do we mean by divisible? Okay, this is for part 1. We say that q of x is divisible by x minus 1 if we can write q of x as x minus 1 times a of x, some polynomial a of x, and q of x can be divisible by x minus 2, meaning it can be written as x minus 2 times some polynomial, let's say b of x. Okay, and if it is divisible by both, by x minus 1 and by x minus 2, then q of x can be written as x minus 1 into x minus 2 times some polynomial, whatever, p of x. Okay, so what does it mean? Like, is like x minus 1 divides q of x. What do you know about q of 1 now? Okay, let's focus now on the last term because it is divisible by both. It is divisible by x minus 1 and it is divisible by x minus 2. Okay, so what do we know about q of 1? Since it's divisible by x minus 1, we know that q of 1 is equal to 0 because 1 minus 1 is equal to 0. So 0 times anything is 0. Okay, we also know that q of 2, because also 2 minus 2 is 0. So also q of 2 is 0. Okay, so now from this fact here, okay, we will determine m and n. Let's substitute 1 in q that is given here. What will we get? Okay, q of 1 will be equal to 1 cubed minus 3m plus 2n 1 squared plus m plus n into 1. Okay, of course, now the exponents on 1 doesn't matter, so we know that this is equal to 0. Okay, so we know that this is equal to 0. So we have 1 minus 3m minus 2n plus m plus n is equal to 0. Now let's simplify this. Okay, so we have minus 3m plus m. This will be equal to minus 2m minus 2n plus n. Okay, minus 2 plus 1. This will be equal to minus n. And we have the plus 1 here. We can take it to the other side and we will have minus 1. Okay, so now we got our first equation from q of 1. Now for q of 2, we also have the same thing. We have, okay, sorry for the noises. Q of 2 is equal to 2 cubed minus 3m plus 2n 2 squared plus m plus n into 2. This will be equal to 8 minus 2 squared is 4. 4 times 3, we have 12m minus, now minus times 2n is minus 2n. Minus 2n times 4, okay, so we'll have minus 8n. Also here plus 2m plus 2n. What do you know about q of 2? Q of 2 here is equal to 0. Okay, so we can put all of this equal to 0 and we will do the same. Minus 12m plus 2m. This will add up to minus 10m. Okay, minus 8n plus 2n. This will be equal to minus 6n. And plus 8, we can take plus 8 to the other side. We will have minus 8. And this will be our second equation. Okay, so now the system, our system of equations is this one. Minus 10m minus 6n is equal to minus 8. Okay, now we can solve this one on the calculator using a calculator, or we can solve it by hand. How do we solve it by hand? There is many methods: comparison method, elimination method. Okay, so using, let's say, the elimination method, we can multiply the first equation by minus 5. By doing this, minus 5 times minus 2 is plus 10. So this equation will be plus 10. We will have here plus 10m, which will cancel out with this one, minus 10m. Okay, so this system will be written like this. After multiplying this by minus 5, we will have 10m minus 5 times minus n is plus 5n. And we must not forget to multiply minus 5 by this last answer over here. So we'll have this is equal to 5. The second equation stays as it is. So now we can add these two equations. If we add them up, 10m minus 10m will cancel out. Okay, 5n minus 6n, this will be equal to minus n. And 5 plus minus 8, this will be equal to minus 3. So we can know that n is equal to 3. We found n. Okay, and now how can we find m? We can substitute n either in this equation or in that one. Okay, equation 1 seems easier. So we will get what? We will get that minus 2m, okay, minus n minus 1 minus n is equal to -1. Instead of n, we will put 3 here. Now to find m, we can do -2m is equal to 3 minus 1, which is equal to 2, and thus m is equal to 2 divided by -2. Okay, we take this -2 to the denominator, we divide by -2 on both sides. This will be equal to -1. So we found m is equal to -1, and n here is equal to 3. Okay, so now we finished part 1. We have to move to part 2. Now what is q of x? We can substitute instead of m its value and instead of n its value, and we will get, okay, we will get this. Okay, so if we substituted m and n after finding them, okay, we can take this -1 and put it here and here, okay, instead of m. So we'll get, we put -1 here and here, as you can see, and the same applies for n. We substituted n is a 3, okay, so we substituted instead of this n and this n the value of n, 3. So this is a 3 and this is 3, and using the calculator we can find the coefficients. Okay, so we will have this polynomial q of x is equal to x cubed minus 3x squared plus 2x. Okay, now in the second part they ask us to deduce a factorization of q. Okay, so as we said, we know that q of x, okay, q of x is equal to x minus 1 into x minus 2 times some polynomial p of x. Okay, what do we know about p of x? What's the degree of p of x? Okay, let's see. The degree of q is from here the highest exponent, which is 3. But since q is written as the product of these 3 factors, okay, then أخذنا rule, this will degree of q will be equal to the degree of x minus 1 plus the degree of x minus 2 plus the degree of p of x. So again, we know that the degree of q is 3, the degree of this one is 1, the degree of x minus 2 is also 1. So how much is the degree of p of x? It must also be 1. So 1 plus 1 plus 1 will be equal to 3. Okay, so we have degree of p of x. Degree of p of x, which will give us that degree of p of x is equal to 1. Okay, so now what can we write? If we want to solve it normally, we will do this. We will write q of x is equal to x minus 1 into x minus 2 into, what's the general form of a polynomial of degree 1? Because it only have x as the highest power, x to the power 1 as the leading term. So the coefficient of x will be a plus b. Okay, this is the general form of a polynomial of degree 1. Now we can multiply all the coefficients and continue as usual, but they asked us to deduce a factorization. Okay, so we will do the deduction in 2 ways. We can do it in writing it in this way: a times x times b. I gave you a note in class that the coefficient here of x is 1. Here the coefficient of x is 1, and here the coefficient of x is a. Now when we multiply, we'll only get one term, x cubed. So we have this one times this one times this one will give us x cubed. Then you will have x cubed, and the coefficient of x cubed will be a. Now what's the coefficient of x cubed here in q of x? It is 1. Okay, so we can directly notice that A is 1. Okay, we can directly say here that so A is equal to 1. And also, how can we deduce the constant term B? Also, we have -1 times -2 times a plus B. If we multiply these, we will get the constant term, which is here +0. Okay, we don't have any constant term. So if we multiply these, what will we get? We will get -1 into -2 into B is equal to 0. Okay, so if the product of three numbers is 0, then B must be equal to 0. Okay, we can divide by 2 on both sides, and you get that B equals 0. So this is one way of deduction. A is equal to 1, B is equal to 0. So what is P of X? Okay, P of X اللي هي AX plus B now is equal to 1x plus 0, so it's simply equal to x. Okay, write this down, please. But we'll do another method. Okay, it's better for deduction, and it's not always applicable, but in this part it is. Okay, we can directly deduce because there is no constant term. Okay, because there is no constant term, even without talking about the degrees. Okay, even without mentioning the degree at all. Okay, let's leave them here. But we know that the degree is 1. So Q of X is x cubed minus 3x squared plus 2x. When the polynomial has no constant term, then we can take x as a common factor. We are left with x squared minus 3x plus 2. Okay, and we know that x minus 1 and x minus 2 are also factors of Q of X. So we can write this now as x into x minus 1 into x minus 2. Okay, why now are we sure that there is no polynomial A of X here, for example? Because we know that the degree is 3. Okay, we know that the degree is 3. This polynomial here, P of X, must be of degree 1, as we just calculated here. Okay, so what's missing is only this polynomial X. Okay, this monomial X. For the third and the last part, we want to solve that Q of X is less than or equal to 0. Okay, now how do we do this? Okay, so to solve this part, we'll use this table called the table of sign. Okay, table of sign. And we always, when we want to solve such a question, Q of X is less than or equal to 0 or greater than or equal to 0, we have to use the factorized form of Q of X. Okay, the expanded form. Using the expanded form, we cannot solve this part. So we start by x. Okay, first x goes from -infinity, okay, to +infinity. All the real numbers, from the smallest one to the largest possible one. And here in these boxes, we put the factors of Q of X. And we have x, we have x minus 1, and we have x minus 2. And in the last row, we will have Q of X. Okay. Okay, first we find the roots. When does each factor is equal to 0? First one is x equal to 0. It's very simple. It's equal to 0 at 0. When x here is equal to 0, draw a vertical line. Okay, this should be a straight line. But at x equals 0, this is 0. Now when is x minus 1 equal to 0? X minus 1 is equal to 0 when x is equal to 1. We take the minus 1 to the other side. So we have here a 1. At 1, x minus 1 here is 0. Okay, and x minus 2 also. 1 is x minus 2. equal to 0 when x is equal to 2. So we draw also a vertical line at 2, and this will be equal to 0 at 2. Okay. Now, before 0, is x negative? Let's take a value, for example, here, which is -1. If x is -1, then it is negative. Okay. Now, if x is negative here, before it's 0, okay, then it is positive after the 0. Okay, so it's positive here, here, and here. For x -1, we know it's 0 is here. Okay, now is it positive here and negative here, or is it the other way around, yani negative here and positive here? How do we know? We take a value and we substitute it. Okay, for example, let's take 0. 0 is before 1. If we substitute 0 here, what we'll get in this factor? What will we get? Okay, we will get 0 minus 1, which is equal to -1, which is negative. Okay, so before 1 here, this term is negative, and after the 0, this is positive. And for x -2, we can also do the same. If we substituted 0 in x -2, we'll get 0 minus 2, which is -2, which is negative. So we know that before 2, this is negative, and after 2, this is positive. Okay, now these are the factors, and they are multiplied by each other. So here, to find the sign of q of x, for example, okay, what must we do? We must multiply the signs together. Yeah, minus times minus is plus, times minus, it is minus. So here in the first cell, we will have a minus. Here, plus times minus is minus. Minus times minus is plus. So we'll have a plus here. Plus times plus is plus. Times minus, we'll get a minus. Also, a negative times a positive is a negative. A negative times a positive stays also a negative. Okay. And of course, 0. This is 0. 0 times anything will be 0. And the other 0 will also be 0. And q of x has 3 roots, as we noticed. The 3 roots are 0, 1, and 2. Okay. Now they want us to solve that q of x is less than or equal to 0. Okay. So as we can notice here in this interval, q of x is positive. So we do not want this interval, but we want everything else. Okay. How can we write this in the form of an interval? Okay. We want all the numbers from -infinity to 0. We want all the numbers from 1 till +infinity. Okay. So q of x is less than or equal to 0 when x belongs to what interval? From -infinity to 0. Do we want 0, or do we open the interval at 0? Let's check the question. The question needs us to find q of x less than or equal to 0. Okay, so they want q of x to be equal to 0. And at 0 here, we can see that at 0, q of x is 0. So we want this 0 sign and union. Now this second interval from 1 till +infinity. So we also want 1 because q of x is equal to 0 at 1. Okay, it is equal to 0 at 1. So we want it when it is equal to 0. By this, we are done solving exercise 15 in the polynomials. Please copy these in your copybooks and solve as a homework for Tuesday exercise 6 parts 2 and 3, and also exercise 8 parts 2 and 3. Okay, enjoy your time and see you on Tuesday, hopefully.